Hello everyone. On this video we will be looking at more basic differentiation rules. So we'll be looking at the sum and difference rule, the product rule, and the quotient rule. Alright. So first we're going to check out the sum and difference rule. Okay, and that states that if you have the derivative of f of x plus g of x, that's going to equal, basically you just kind of distribute it to both terms, if you kind of think of it that way. So that's the derivative of your f of x plus the derivative of your g of x, which is equal to f prime of x plus g prime of x. Okay, same thing with subtraction. You have the derivative with respect to x of f of x minus g of x. Kind of separate that a little bit. And that's going to equal the derivative of your f of x minus your derivative of your g of x, which is equal to f prime of x minus g prime of x. Okay, so we're going to go ahead and prove the sum because the difference rule is pretty much proven the same way. Okay, so if we look at the sum rule for differentiation, we know that the derivative with respect to x of f of x plus g of x is equal to the limit as h approaches 0 of what you're differentiating, but f of x plus h. So you have f of x plus h plus g of x plus h minus f of x plus g of x all over h. Alright, so we're going to go ahead and distribute that minus sign, move the equal sign over a little bit. So we have the limit as h approaches 0 of f of x plus h plus g of x plus h minus f of x minus g of x, and all of that over h. Alright, so now we're going to kind of shuffle these around a little bit. So you have the limit as h approaches 0 of f of x plus h minus f of x, and at the same time we're going to separate these all over h, plus we're going to do the same thing here, g of x plus h minus g of x all over h. Alright, so we kind of move the f function and the g functions next to each other and separated them both over the same h denominator. Alright, so if you remember your properties of limits, you go ahead and apply the limit to both of those terms. So the limit as h approaches 0 of f of x plus h minus f of x all over h, plus the limit as h approaches 0 of g of x plus h minus g of x all over h. Alright, and you see here that this first term is pretty much the definition for f prime of x, plus this term, the definition of your g prime of x. So the derivative of f of x plus g of x is f prime of x plus g prime of x. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and look at an example. Let me pull the papers down. Alright, so for example, what if we wanted to find all values of x where f of x equals 25 over 3 x to the third plus 10 x squared plus 4x minus 7 has a horizontal tangent line. Alright, so first thing we want to do is we want to know exactly what it is we're looking for. And that's getting an understanding of what they mean by a horizontal tangent line. A horizontal tangent line is really where the slope is equal to 0. That's about the simplest way to explain it. That the slope equals 0, or to make it a little more relevant to what we're doing, your f prime of x is equal to 0. Okay, so this is kind of our goal, to find out where our f prime of x is equal to 0 in order to find out where our horizontal tangent line will be. Alright, so first thing we have to do is find our derivative, our f prime of x. Okay, so f prime of x is equal to, if you look at your f of x, you have 25 over 3 x to the third, so we just get our 25 over 3, put it right out front, and we have the derivative of x to the third, plus we have our 10x squared, so it's just a constant, we can put that out front. So that's the 10 times the derivative of x squared, plus you have 4 times x, so you can put the 4 out front, times the derivative of x minus the derivative of 7. Alright, so your f prime of x is going to equal, you have your 25 over 3, derivative of x to the third, going to bring down your 3. You have x to the 3 minus 1, so you subtract 1 after you bring it down, plus you have 10, the derivative of x squared, you're going to bring down that 2, times x, then you're going to subtract 1, plus 4, remember the derivative of x is just 1, so you can make it x to the 1 minus 1 if you want to, minus 0. So we already knew that was 0 just by looking at it. Alright, so if we go ahead and simplify those terms, if f prime of x is equal to, you can see these 3's cancel each other out. So you have 25 x squared plus 10 times 2 is 20, so you have 20 x to the 2 minus 1, which is just 1, plus 4. Okay, so we found our f prime of x. Okay, so now that we've done that, we have to find out the x values where we have our horizontal tangent line. So in other words, find where f prime of x is equal to 0. Since this is our f prime of x, we have 25x squared plus 20x plus 4 equals 0. Okay, which isn't too bad, because if you look at this one, you'll notice it's a perfect square trinomial. Okay, so here, forgot what a perfect square trinomial looks like. It's a squared plus 2ab plus b squared is equal to a plus b squared. That's perfect square trinomial. Alright, so to find our perfect square trinomial, our 25x squared, we're going to make that 5x squared. The middle term, we're going to leave that blank for now. And that 4, we're going to make that 2 squared. Okay, so you have a squared plus 2ab plus b squared. Okay, so this 5x is your a, and 2 is your b. So that means if this middle term, 2 times a times b, is equal to 20x, you can just plug it right in there. Okay, so that's going to equal 2 times a times b, which is 20x. So since this is 20x, you can just plug it a plus b squared, so 5x plus 2 squared. Okay, so this just simplifies to 5x plus 2 squared equals 0. Alright, so if we square root both sides, that's 5x plus 2 equals 0. Solve for x. That's x equals negative 2 over 5. Okay, so that's the value of x on the graph where you would have your horizontal tangent line. Alright, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to the product rule. Alright, so what the product rule tells us is that if you want to take the derivative of two functions that are multiplied to each other, that's going to equal the first function times the derivative of the second plus the second function times the derivative of the first. Okay, and that is literally how I remembered this setup. I would say first times the derivative of the second plus the second times the derivative of the first. Okay, so that's literally how I remember it. Okay, so let's go ahead and prove this one. Okay, so if we have the derivative with respect to x of f of x times g of x, that's going to equal the limit as h approaches 0 of f of x plus h g of x plus h minus f of x times g of x all over h. Okay, so what we're going to do is we're going to kind of manipulate this a little bit. So we're going to add and subtract f of x plus h times g of x in our numerator. Okay, so I'm going to move my equal sign over a little bit. So it's going to equal the limit as h approaches 0. You have f of x plus h times g of x plus h. We have minus f of x plus h g of x plus f of x plus h g of x. Okay, so we added and subtracted it, so basically we just added nothing. Minus f of x g of x all over h. Okay, so we're going to go ahead and separate these. It's going to equal the limit h approaches 0. So we have f of x plus h, g of x plus h, minus f of x plus h times g of x all over h, plus f of x plus h times g of x minus f of x times g of x all over h. Alright, so here we're going to go ahead and factor out the f of x plus h from these two, and we're going to factor out the g of x from those two terms. And at the same time, we're going to go ahead and distribute the limit to those terms. So we have the limit h approaches 0, f of x plus h times g of x plus h minus g of x all over h, plus, remember here we factor out the g of x, so you have the limit h approaches 0 of g of x times f of x plus h minus f of x all over h. Okay, so once again, we're going to distribute our limits to the two factors. So you have the limit h approaches 0 f of x plus h times the limit g of x plus h minus g of x all over h as h approaches 0, plus, go ahead and distribute it to those two. You have the limit h approaches 0 of g of x times the limit h approaches 0 f of x plus h minus f of x all over h. Okay, so what does this tell us? Well, if you use direct substitution for this one, you can just plug in h equals 0, which leaves you the limit of f of x, which is f of x. So this is just f of x. This one here, if you look at it closely, just the definition of g prime of x. And here, if you use direct substitution, the limit as h approaches 0, there is no h to replace, so this is just g of x. And if you look at this one, this is just your definition, f prime of x. So you end up with f of x times g prime of x plus g of x times f prime of x. Okay, and that is your proof. Okay, so if you are still writing, feel free to press pause, but we're going to go ahead and move on to our example. Okay, so let's say if we want to find the derivative of h of x is equal to 3x minus 2x squared times 5 plus 4x. Alright, so I'm just going to go ahead and rewrite that. So h of x is equal to 3x minus 2x squared times 5 plus 4x. Okay, so that makes this, since it's our first one, we'll make this our f of x, or you can just call it first if you want to. And this is our g of x. So you have two functions being multiplied to each other. Alright, so let's find the derivative, which is our h prime of x, is equal to our first times the derivative of the second, plus the second times the derivative of the first. Okay. Now, before we go any further, we have to find our g prime of x and f prime of x. Okay, so your f prime of x, remember this is your f of x. So you have 3 times the derivative of x, which is 1. So 3, I'll just go ahead and write it out. Derivative of x minus 2 times derivative of x squared. Okay, so that gives us f prime of x equals 3 times 1 minus 2 times the derivative of x squared is 2x. So your f prime of x is equal to 3 minus 4x. Okay, put a little square over that because we are going to need it. Now, your g prime of x. That's going to equal derivative of 5 plus 4 times the derivative of x. Okay, so your g prime of x is going to equal 0 plus 4 times 1. Derivative of x is just 1. So your g prime of x is equal to 0 plus 4, which is just 4. Alright, so now we just go ahead and plug it in to this formula here. So h prime of x is equal to f of x, which is 3x minus 2x squared times g prime of x, which is 4, plus g of x, which is 5 plus 4x, times f prime of x, which is 3 minus 4x. Okay. Now, if you wanted to, you could have written your f of x, g of x, f prime of x, g prime of x all in line. This way you didn't have to bounce around. Whichever way is most comfortable for you. Alright, so this one, we just have to distribute the 4. And this term, we just FOIL it out. Okay, so we have h prime of x is equal to 4 times 3x is 12x minus 8x squared plus, we FOIL, we have 15 minus 20x plus 12x minus 16x squared. Okay, so if we combine our like terms, we have negative 8x squared and negative 16x squared. So h prime of x equals negative 24x squared. We can go ahead and cross those out. We have 12x minus 20x plus 12x. So, and we should have, yep, so you have 24x minus 20x, which is positive 4x. And you just have 15, that's the only constant, so that's plus 15. Okay, so that is your derivative of h of x. Alright, so if you are still writing, feel free to press pause. Now we're going to look at the quotient rule. Okay, so the quotient rule states that you have the derivative of a function divided by another function, and that's going to equal your denominator times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. And that's assuming that your denominator does not equal 0. Alright, so let's go ahead and prove that this is the case. Okay, so we have our derivative of f of x over g of x, which is equal to the limit as h approaches 0 of f of x plus h over g of x plus h minus f of x over g of x all over h. Okay, so let's go ahead and get common denominators in your numerator. So we're going to multiply this one, first term by g of x over g of x, and this term over here by g of x plus h over g of x plus h. So you have the limit, h approaches 0, g of x over g of x times f of x plus h over g of x plus h minus f of x over g of x times g of x plus h over g of x plus h all over h. Alright, so since we have our common denominator, at least up here, we have the limit as h approaches 0 of g of x times f of x plus h minus f of x times g of x plus h all over your common denominator of g of x times g of x plus h. And instead of making that all over h, we'll just go ahead and put our h right there. Alright, so again, just a little bit of manipulation. We're going to add and subtract f of x times g of x in our numerator. Alright, so let me move this up a little bit. Move that equal over so it's not squeezing everything in. That's going to equal the limit as h approaches 0 of g of x times f of x plus h. So it's minus f of x times g of x plus f of x times g of x, and minus our f of x times g of x plus h all over g of x times g of x plus h times h. Okay. Now this one we're going to factor out the g of x, and this one we're going to factor out the f of x. So we'll factor and we'll factor. Just factoring going on. So we have the limit as h approaches 0. And the g of x that we factor out, we're going to go ahead and just put that right on the outside, which leaves us with f of x plus h minus f of x all over h times g of x times g of x plus h minus, because we're going to factor out the minus f of x. And the reason why is because we need g of x plus h to be positive. So we're going to factor out minus f of x. And that's the limit of g of x plus h minus g of x all over h g of x plus h. And that's as h approaches 0. Alright, so now what we're going to do is, using the properties that we learned about our limits before, we're going to get the limits of our numerator and denominator. Okay, so that's g of x times the limit as h approaches 0 of f of x plus h minus f of x, and we're going to bring that h up top all over h, divided by, bring that up some, the limit as h approaches 0 of g of x times g of x plus h. Okay, so we're going to do the same thing here. So minus f of x, we're going to take the limit of the numerator. So you have the limit as h approaches 0, g of x plus h minus g of x. We're going to bring that h right up top, all over h, divided by the limit as h approaches 0 of g of x times g of x plus h. Alright, so now we're going to look at each individual term. And actually, if you want, you can put that g of x up top instead of out front. It'll still work, make things a little easier. Okay, so we have g of x, the limit of f of x plus h minus f of x over h. That's just your f prime of x. Minus f of x, and this is just your definition of g prime of x, all over, you see the limit as h approaches 0. If you use direct substitution and make h equals 0, you have g of x times g of x. Same thing here, g of x times g of x. So this just becomes g of x squared. And that is how we get our definition for the quotient rule. Alright, so if you are still writing, feel free to press pause. But we're going to go ahead and move on to our example. Okay, so let's say for this example, you want to find the derivative of f of x is equal to 5x minus 2 over x squared plus 1. Okay, so the first thing we're going to do is we're going to look at our quotient rule. Okay, so your f prime of x would equal your denominator. So you have x squared plus 1 times the derivative of your numerator minus your numerator times the derivative of your denominator all over your denominator squared. Alright, so let me move that over a little bit so I won't run out of room. So you have your x squared plus 1 times the derivative of 5x minus 2. So the derivative of 5 times x, well, derivative of x is just 1, so that's 5 times 1, so that's 5. And the derivative of 2 is a constant, so that's just 0. So you have 5 minus 0, which is just 5, minus 5x minus 2 times the derivative of x squared minus 1. So the derivative of x squared, just bring down that 2. So you have 2x. And derivative of 1, derivative of a constant is 0, so that's just 0. So 2x plus 0 is just 2x. And that's all over x squared plus 1 squared. Okay, so now moving on, we're going to go ahead and just distribute that 5 and distribute that 2x. So f prime of x is going to equal 5x squared plus 5 minus 10x squared plus 4x. All over x squared plus 1 squared. Okay, so really we can combine these two. F prime of x will equal negative 5x squared plus 4x plus 5 all over x squared plus 1 squared. Okay, you know that's the final answer because you can't simplify anything else. You can't factor this out and then cancel out your x squared plus 1 anywhere. So this is actually your final answer. Alright, so hopefully that made sense, and I will see you on the next video.